Hey guys, Mr. Longbreak here, and congratulations, you've made it to the end of the school year. This is the last lesson that you guys will have for 2020. So, um, congratulations, and this is going to be over Newton's second law. Newton's second law is the second of three laws. We won't get to the third law, and it is essentially a formula that shows the relationship between three variables. And that formula is F equals ma. And the F stands for force, that fancy word that this unit is all about, and its unit will be newtons, or capital N. The M stands for mass, and usually that mass is actually going to be in kilograms. We're used to it just being grams, but for this formula it's going to be kilograms. And then the A is acceleration. And we've heard of that word before. It's how much something's speeding up or slowing down, and its unit is meters per second squared. So that is what each of those variables stands for. And force will equal something's mass times something's acceleration. And basically what that means is, as force increases, you're going to have a higher acceleration. That should kind of make sense. So say you were, for instance, driving a car. The more force you apply to that engine, the further down you push that pedal, the more you're going to accelerate. So if you were to push down the pedal really hard, then you would be applying more force and you would accelerate more. Versus if you barely push down the pedal and you don't apply a lot of force, then your acceleration will be lower. It also shows the relationship between mass and force. If you have a greater mass, you're going to have to apply a greater force. And that should also make sense. Let's look at a bowling ball and a soccer ball. If you were to roll a bowling ball, you're going to have to apply a lot more force to that bowling ball to get it to a certain speed. Versus a soccer ball, you'd have to apply less force because it's less massive to get it to a certain speed. So that's the relationship between the variables, but more importantly, here is the equation that we're going to use for these three examples. So this is going to be exactly like the assignment that you're going to have to complete, and we'll start in with example number 1. It says calculate the force of a 75 kilogram cheetah that is accelerating 8.93 meters per second squared. So over here, the given, that's where we're going to label our variables. So that 75 kilograms is mass. That 8.93 is acceleration. And then it's asking for force. And now I'm simply just going to plug in those variables to our equation that we just learned about above. So F equals ma. F is what we're looking for, so I'll leave it as F, or you could substitute in X. M is 75, and A is 8.93. So now to solve for force, we just are going to plug into our calculators 75 times 8.93, and we get 669.75, and we'll go ahead and just round that to 670 newtons is the unit for force. So our answer, 670 newtons. Okay. Next, it says an automobile with a mass of 1,000 kilograms accelerates when a traffic light turns green. Use the force diagram to calculate the net force. Then find the car's acceleration. So what are we given? We're given the mass, which is 1,000 kilograms. And then we're given this picture down here. And so we're not necessarily given the net force right away, but we have all the information in order to calculate that. So I'll leave that blank for now. And then it is asking for acceleration. So that's the variable we're looking for this time. So first let's calculate the net force. And we have two arrows going in the same way, meaning, or same direction, meaning we're going to add them together. So 39 plus 11, that is going to give us 50 newtons to the right, since they are both going in the same direction. And so I'm going to plug in for my F 50 newtons, and then I can plug those variables into our formula. So F equals ma, 50 is F equals M, which is 1,000 times A. If you want to substitute in X, you can. And to get A by itself, we are going to divide both sides by 1,000. So I'm going to divide this by 1,000 and this by 1,000. And when I do that, I'm going to get my answer for A. So I'm going to plug in 50 divided by 1,000, and we get 0.05. And our unit for acceleration is meters per second squared. So that time we solved for acceleration, and then the first one we solved for force. This last one we're going to be solving for mass. So let's read through this one. It says a bike rider was traveling on a bike accelerating 30 meters per second squared. Calculate the mass of the bike rider. So what we're given an acceleration, 30 meters per second squared. And once again, we're not necessarily given the force right away, but we're given a picture to determine the net force. And this picture is a little bit more difficult to find the net force, and we'll get to that. So I'll leave it blank for now. And it's asking for mass. So first, let's calculate the net force. And I'm going to do that by using this force diagram. So I have two arrows going in the same direction and then an arrow going in the opposite direction. So arrows going in the same direction I'll add. So 10 plus 55 is 65. And then I have this other arrow going in the other direction. So I'm going to do 65 minus 60. That will give me 5 newtons. And that is the net force of this particular bike. And it's going in this direction because there's more force being applied to the right than to the left. And so I'm going to plug in 5 newtons for my force, and then I just plug it into our formula from up above. F, which is 5, equals M, which is what we're solving for, times A is 30. So to get M by itself, we're going to divide both sides by 30. So 5 divided by 30, and we get 0.166. And our base unit for mass is kilograms, and so my answer will be 0.166 kg, or kilograms. So that is an example solving for each of the variables in our F equals ma equation and Newton's second law. Congratulations again on making it to the end of the year. I'm really disappointed I can't say bye in person. You guys have been an absolutely amazing class. I hope to have some of you next year in chemistry. But if not, please stop by. I'm going to be in the same room. I miss you guys all a ton. And have a fantastic summer. You guys deserve it for sure. All right, we'll talk to you later, guys.